choosing appropriate measures. So when we say choosing appropriate measures, what we're talking about here is, does the mean accurately describe what's going on? Does the median accurately describe what's going on? Which takes us the whole way back to 7.1, where we said which one more represents the typical value of our data set. So when a distribution is symmetric, as you see here, we're going to use the mean to describe the data set because there's no outliers. There's not a low outlier. There's not a high outlier. So the mean is going to be right in the middle, which is our typical data set. And then for our variation, this is for our center, to describe the center. This is for our spread, okay, or to describe how spread out it is. We're going to use the standard deviation to describe the variation. Now, when a data set is skewed, what's going to happen here is over here on the left, when it's skewed left, these are going to be more of your outliers, which are going to take the mean and they're going to pull it down. It's going to make the mean lower. So we don't want to use the mean if it's kind of been skewed out to the left, so you're going to use your median. Okay, same thing up here. If your data is skewed right, what that's telling you is that you're going to have some outliers up here to the right. So it's going to take your mean and it's going to push it too high because somebody did something too high. So you don't want to use your mean, you want to use your median, which is going to be more your typical value of this data set. So if your data is skewed, your center, you're going to want to use the median. And then for your spread or your distribution, you're not going to want to use the standard deviation, which relies on mean. You're going to want to use the 5-number summary to describe kind of how far spread out it is. Example 3, use the shape to choose the most appropriate measure of center and variation. So, example 3, you record the numbers of email attachments sent by 30 employees of a company in 1 week. Your results are shown in the table. Part A, display the data in a histogram using 6 intervals beginning with 1 to 20. So if we want to get this in a histogram, the first thing we have to do is we have to get it in a frequency table. Okay, so we're going to take our data over here. We're going to get it in a frequency table. In a frequency table, you need labels. Over here, this is always your frequency. Then over here, we're describing what we're talking about. And on this example, we're talking about number of email attachments sent. And then it specifically tells us that we're going to begin with the interval from 1 to 20, and we have to use 6 intervals. Now, on a histogram, when you're doing your intervals, it's kind of like a number line. So if this goes from 1 to 20, then this one's going to pick up at 21. Now, this has like 19 numbers between it, or you can think of counting equally. If this is 1 to 21, then I'd have to go 41, 50, 61, 81, and then this one's finally going to be 101. So here you're just counting by 20s, 20, 40. So over here you're going to do the same thing. 20, 40, 60, 80, 100, 120. So, and then it makes a number line. So you have 1 to 20, then you pick up a 21. To 40, then you pick up a 41. So you're not missing any numbers. Now, the frequency, this is going to get a little more difficult, and I'm really going to encourage you to pause your video and start counting because this is going to take a while. You have to find how many numbers over here are between 1 and 20. So, no. Well, that would be 5. And then 16, which is 2 numbers. Then you're going to find all the numbers between 21 and 40. Pause your video and do this. I've already done it. 3, 9, 10, 4, 2. Then the way you should check this is when you're doing a frequency table, in here, if you add all of these, oh, I'm sorry, let's go back. If you add all of these, this is 1, 2, 3, 4, 5 by 6. There are 30 numbers in this table. So if you add all of these, 2, 3, 9, 10, 4, 2, that's 30, which tells me I got all of my numbers. If you add these up and it doesn't match what's over here, you probably screwed up. Now we're going to make our histogram. So I'm going to put my intervals down here. And then on my frequency, I have to make it the whole way to 10. So I'm going to count by twos. 2, 4, 6, 8, 10. Don't forget to label. So this is number of email attachments. And then this is your frequency, which we can abbreviate FREQ. And then we're going to make our bars. So here we went 2, and then 3, and then 9, and then 10, and then 4, and then 2. Okay, so part A, display the data in a histogram using 6 intervals. We have done that. Now, part B. Which measures of center and variation best represent the data? Explain. So in order to answer that question, we first have to figure out, well, what's the spread? Is it skewed left? Is it symmetric? Or is it skewed right? Looking at this data, it's got 2 low bars on the left, it's got 2 low bars on the right, it's got 2 upper bars over here. So I'm going to call this symmetric. So given that this is symmetric, it probably means there's not really a whole lot of outliers, either too low or too high here. Everything looks evenly spaced, which means we're going to use the mean to describe the typical value or the center. And we're going to use the standard deviation to describe how spread apart it is. And my explanation there would be because the data is symmetric.